My name is David Silver. I'm at Udacity. I'm actually in one of our studios, so you can see a microphone and some other stuff hanging above my head. And this is an overview of our Introduction to Neural Networks lesson from the Udacity Self-Driving Car Engineer Nanodegree program. In this lesson, students learn to build and train neural networks, starting with the foundations in linear and logistic regression and culminating in backpropagation and multi-layer perceptron networks. Let's click through and see what all of that even means. So the lesson starts out with Ryan and I in a garage. That's my colleague Ryan Keenan, and that's me talking about how deep learning affects self-driving cars. And then we jump pretty quickly to a couple of my colleagues. This is Matt Leonard in the middle and Luis Serrano. They both work at Udacity on our deep learning nanodegree programs. And they're going to teach most of this lesson, starting with what linear regression is and what logistic regression is, and then how we can build up from there to understand what neural networks are. Neural networks are essentially tools that take data and learn to do something based on that data. So you might send them pictures of cars and the neural networks might learn to recognize what a car is. Or you might send them pictures of the road and the neural network might learn what direction to turn the steering wheel based on how the human driver turns the steering wheel when a human driver sees that picture of the road. That type of thing. That's actually machine learning generally. Neural networks specifically use these layers of what are called artificial neurons to learn how to do different things and extract meaning from data. So if I fast forward to this image here, this is kind of conceptually what a neural network might look like. It's these layers of artificial data, artificial neurons that take data as input, maybe from the left side, and then run that data through the neurons and produce an output, maybe here on the right side. And so we'll learn about the perceptron, which was historically kind of the earliest type of artificial neuron, and how we can string together perceptrons to implement functions like and or not. And from there, we can actually build up functions that calculate much more complex things. And we use something called gradient descent and ultimately something called backpropagation to run data through the network and then figure out how to train the network based on that data. So you see this video here, or if I scroll down this image here, essentially as we run data through the network calculates an output, and then the network tests how accurate or inaccurate that output is. So if we run data through the network and we're looking for the number 5 as output, backpropagation figures out, if we got the number 6 and we're looking for the number 5, we need to go back through the network and adjust all of our values in the network, these internal weights on these artificial neurons, so that the next time we run an input through the network, we get a 5 instead of the 6 that we saw this time. That's a kind of a simplification of how backpropagation works, but that's at a high level what the concept is. And so by the end of this lesson, you're learning how to implement backpropagation and the math behind neural networks, and then in a future lesson, you'll actually implement your own neural network, and you'll see that in the next lesson that I cover. So I'll show you here a video where my colleague Luis Serrano starts with something called logistic regression and ultimately uses that to explain at a high level what a neural network does.
Okay, so let's look more carefully at this model for accepting and rejecting students. Let's say we have a student 4 who got 9 in the test, but 1 on their grades. That student gets accepted according to our model, since they are over here, on top of the line. But that seems wrong, since a student who got very low grades shouldn't get accepted. So maybe it's too simplistic to think that this data can be separated by just a line, right? Maybe the real data should look more like this, where these students who got a low test score or low grades still do not get accepted. So it seems that a line won't cut it anymore. What's the next thing after a line? Maybe a circle? A circle could work. Maybe 2 lines? That could work too. Let's go with that. Let's go with 2 lines. And how do we find these 2 lines? Again, we can do it using gradient descent to minimize a similar log loss function as before. This is called a neural network. Now the question is, why is this called a neural network? Well, let's say we're working in a very slow computer which can only do one thing at a time. So it's not easy to just ask, Is this point in the area bounded by these two lines? We have to split it into separate questions. The first question is the point over the blue line? Let's answer that question based on the 4 black points in the graph. We can see that for these 4 points, the answers are yes, yes, no, and no. The second question is the point over the orange line? And we can see that for the 4 points, the answers are no, yes, no, and yes. Now the third question, will just take the answers from the previous 2 and combine them. So the third question is, are the answers to questions 1 and 2 both yes? And we can see that for these 4 points, the answers are no, yes, no, and no. So they are all no except for the one that is in the green area. Now let's graph each question as a small node. The first question is the point over the blue line? We have a node with the area and 2 input nodes, the test score and the grades. For example, we have a student where the test score is 1 and the grades are 8. The node plots the point and checks if the point is on top of the black line and returns the answer, yes or no. The second question is similar. We input test and grades, and the corresponding node will plot the point and return a yes or a no depending on the point being on top of the orange line or not. Now the third question, are the answers to questions 1 and 2 both yes? We'll just take as inputs the answers to the 2 previous questions and return a yes if the 2 answers are yes and a no otherwise. This is known in logic as the AND operator. Now this is where the magic happens. If we join the nodes for these 3 questions, then we get a neural network. And if we clean it up a bit, we have the following. The first column is where we input test and grades. And the second column is where we check if the point with coordinates corresponding to the test and the grades is on top of each one of the lines. And the third layer, in which we look at the answers from the previous layer and join them with the AND operator. So this is how our neural network will look. Now you may be thinking, something's a little suspicious here. The first 2 nodes look like they take values and check if the corresponding point is on top or below a certain line, whereas the third node just takes yes or no and returns yes or no. Is it possible to see the third node as one of the first 2? And the answer is yes. So let's look at the AND operator in more detail. Let's actually make a little table of what goes in and what goes out. So in the AND operator, if we input a yes and a yes, we get a yes. If we input a yes and a no, we get a no. If we input a no and a yes, we get a no. And finally, if we input a no and a no, we get a no. Now we can think of a yes as a 1 and a no as a 0. In that case, our table turns into this other one. And now, look at this operator in which we enter values 0 and 1 and check if the corresponding point with those coordinates is over or below the line. If we look at the points with coordinates 1, 1, we get that this point is over the line on the green or positive region, so we get a 1. Now if we look at the points with coordinates 1, 0, we see that it's under the line on the red or negative region, so we get a 0. Similarly, for the point with coordinates 0, 1, this point is under the line, so we get a 0. And finally, the point with coordinates 0, 0 is under the line too, so the answer is 0 again. So this is how our final neural network looks. On the left, we have what's called the input layer, where in this case we're inputting the test scores and the grades. Here we have a case where the test score is 1 and the grades are 8. Then this goes through a middle layer called the hidden layer, which will help us with our computations. So in here we can see that the 1 and the 8 become the point with coordinates 1, 8 on the 2 graphs in the next layer. In the top node, the point 1, 8 is on the green or positive region, so the top node emits a yes. In the bottom node, the point 1, 8 is on the red or negative region, so the bottom node emits a no. Now we remember that a yes is represented by a 1 and a no is represented by a 0. Now the next layer, called the output layer, takes the values coming out of the middle layer, namely the 1 and the 0, and it locates the point with coordinates 1, 0. This point is in the red or negative region of the final node, so the output here is a no. Thus, the neural network has received as inputs the values test equals 1 and grades equals 8, and it has outputted a no. This is a simple neural network, but you can see how adding more nodes in the middle or even more layers of nodes can help us map more complex areas in the plane or even in 3 dimensions or higher dimensional spaces. Neural networks are a very powerful machine learning algorithm used in most state-of-the-art projects such as facial recognition, voice recognition, playing chess, and self-driving cars. And we call it a neural network because these nodes resemble neurons in the brain. A neuron will take as input the output of other neurons in the form of nervous impulses and decide to fire a nervous impulse or not. In our case, the neuron takes as input the output of other neurons in the form of numbers and decides to return a 1 or a 0.
So that's lesson 4 of the Udacity Self-Driving Car Engineer Nanodegree program. It's Introduction to Neural Networks. I hope you liked it, and hopefully you even learned something. And if you're interested in signing up for the Nanodegree program, just go to udacity.com/drive and apply today. See you later. Bye-bye.